Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop, and we're building an not an LBSC Tidge, we're building a Raritan, working on a flat car, the Raritan flat car. This is the book that you can get from Tansky Engineering in Eden, New York. He sells all the castings for it, and what we're building, since we just finished the Tidge locomotive, we're building the flat car, which also known as a riding car. Let me show you what some of the pictures look like. Here we go. Inside here, I don't know if these come out very well or not, but the book actually has pictures. A lot of it is a reprint from the book, which is out of print now, and which was originally in editions of the Live Steam magazine, probably back in the late 1970s. Anyway, it's a cool project, a lot of fun so far, lots of detailed parts, plenty to keep you busy if you're a home machinist. In this week's episode, we finished making all the Clevises, all the little brass pins, drilled holes in the pins that we needed. We've made the Clevises to fit for the different applications, and we finally machined and cut out the brakes, and I made an error in the brake thing, so pay attention to that, pay close attention to that if you're making this project, so hopefully you can avoid making the same mistake that I did. Happily, I did figure out a way to resolve the issue and kind of make the best out of the bad situation, so it's definitely worthwhile checking that part out. And we finished up by making a custom jig to bend a little bar that's an integral part of the trucks also. So I think you'll find this week's episode interesting. I sure hope so. If you have any questions or want to make any comments, please do so. I always like to see and read those and answer the questions if I can. If you have no questions but you enjoy it and you appreciate this and you want to encourage me to keep posting, just hit the thumbs up button. I appreciate that too. So thanks so much, everybody. I hope you have a great week. And next week, little teaser. Next week next episode, we will tackle the last casting part of the project, but it's the little cast iron wheels. I'm really excited about this. Is going to be very, very fun, and they'll come out looking a lot different and a lot more useful. But they're very cool. These little cast iron wheels that come with the casting set. So I'm anxious to get started on those and looking forward to bringing you next week's episode. So thanks everybody. Hope you enjoy this one. Have a great week. Bye. Next up with the Raritan trucks is making of the Clevises. There's the item number 3511. I need to make 9 of them. These are the shorter ones. They're just under 3/8 of an inch long, and there are 5 of them will have a 1/8 inch hole drilled in the back. 4 of them will have a 3/16 inch hole. So what I did, I cut out 9 blanks. These are the right size, and I've marked them out for the holes that will need to get drilled in them to start with. There's a number 30 hole, which will hold the 1/8 inch pin that'll go through, and then a little further back, in this case 0.188, 3/16 of an inch from the end, I'm going to drill a hole here. It'll be the pilot for milling the slot. So these will all 9 of these will be like this. I keep them in separate groups basically to remind myself, because I'll probably tomorrow I'll be drilling the holes in the back, and this hopefully will remind me that I need to do the 2 separately. There's also 3 adjustable Clevises, which are slightly different configuration, a little bit longer. So what I've done is cut out the 3 blanks for them and laid out. All of them share one characteristic in common. They all have a number 30 hole in, an 1/8 inch in from the end like this, all of these. So that's what I'll do. I'm going to knock that out tonight now that I've got the blanks cut, and then tomorrow we can mill it's getting kind of late. Tomorrow we'll mill the slots, the Clevis slots, and then I can put them all in the 5C collet chuck and put them in the lathe for either drilling and tapping, in this case, the back ends of them. one more thing while I'm yapping here. You might notice my little workspace there. I've organized it. I took a sneakers box here and I put all the different parts. I kept the two sets, the left and the right sets, in separated basically. So I've got them all. I did the same thing with the titch, kind of just a way to keep organized and give myself a little workspace there. So when the clevises are done, I'll be able to put them in here as well. Here's what the setup looks like to drill the initial holes in all these clevises. I've put them in the little slot. I've indicated the exact location where the excuse me, the number 30 hole goes in the side of each of them. So I'm using the soft jaws and the little ledge that I've milled in them before, and I set it up. I use this little block to get them even with the edge, and then I can just go mass production. So I've just finished. This is the last of the small ones. Let me walk over here so you can see the 3 larger ones, and I've got the group of 5 small ones, and then that's the 4th of these. So I can come back tomorrow and flip them over and drill the 9/64 hole in all of them. That'll go down. There we go. It's deeper on these. Anyway, you get the picture. So once that's done, then I can go ahead and start milling out the slot. I'll use an 1/8 inch end mill like I did on the other parts, and just file out the little remaining end, and then I can round them, then put them in the 5C chuck and machine the backs of them. It's been a productive afternoon getting the little clevises milled out. I originally was going to center drill them and then drill them with the 9/64 drill and then mill them out. But what I realized was when I would drill down here, the vertical drill, it would catch the opening here, the pre-drilled cross opening, and it would make the drill bit catch and wiggle. So what I ended up doing was breaking one of my 1/8 inch end mills, but luckily I have several. I used an 1/8 inch end mill. This is my little setup here, if you can see that. Let me adjust the light and zoom in. I'm using my aluminum soft jaws, and because it's so wide, I've got a dummy piece in here holding it in place. And I just plunged down all the way, and then I came back up and I milled 50 thou at a time to get down to the full depth. So that's the last one, and now we clean them up and put them in the lathe. Alright, well, that was a productive day's work. Got all the adjustable long clevises done. Got the 4 small ones with the 3/16 inch hole drilled in the back, and then the 5 small ones with the 1/8 inch hole. And I've gone over them with a little file and cleaned them up a little bit. So I think they're going to be good to go. Next up, I'm thinking about the brake disc. So I was just playing around with my little 3-jaw chuck that goes 3-jaw 5C chuck. And I can hold, at least grip it from the inside and turn the outside of it to the right diameter. So we'll see. I'll keep making the brass pins for the clevises. I need to make 20 of them total. I already made 1, or actually 2. This is the second one here. And so I'll show you in a minute why I made them this long, but I made the shank of it 350 thou, and then the head is a 1/16 of an inch. So I turned it down to 1/8 of an inch, and it's 3/16 inch stock that we're starting with. And I've just mic it just to be on the safe side. I use the DRO, but I mic it, and I got it right at 1/8 of an inch. So we're good to go there. Now I remove this cutter, the diamond tool holder, take that off, and I'll put my cutoff tool, line it up, and cut it off. Here's the finished batch of pins for the clevises. I made an extra one just in case. The next thing is to drill a hole, excuse me, 1/16 of an inch in from the end. And as you can see here, what I've got is a little Sureline milling vise. I bought this thing off eBay. They're really nice little machines. They've got a couple of V-grooves cut in them. You can't really see it. One vertical here, and then there's one that goes along the fixed jaw, and that's what's holding the pins in place. And what I've done is blued them and made a little mark. I don't know if that's showing up or not. Let me get the camera over. But I made a little mark with the dial caliper there. As you can see, I've got it set on 62.5 thou. So I can see that mark. My plan is to put this in the Bridgeport mill vise, and then indicate using my wiggler the spot on 1/16. Then I can mark my DRO and then measure over and indicate the 1/16 inch spot on this side, and basically write down the setting. And I can go ahead and I can put an end mill in, make a little flat spot, and drill a hole for the wire. And in this case, I would use a 56 drill. If I can find a sharp one, I will, because I don't really need the diameter of a 55 drill. That's 52 thou. The 56 drill is 46 thou, and the wire I'm using is 18 gauge that I bought at Lowe's, and it's measures out about 37 or 38 thou. So it's stiff copper wire, so having a little extra space in there is not going to be a bad idea. So anyway, that's the game plan. I'll bring you back and see if it works. In case you're wondering what I meant when I said if I can find one, well, this is a case in point. Here are some number 56 drills that I bought, and I think I probably bought these at a recent train show that was mostly small gauge, you know, HO and O and N gauge and all that kind of stuff. But sometimes you go there and people are selling their old supplies of tools and odds and ends, and I'm pretty sure I got this for $1, not even $1.79. You know, they'll have dozens of these things in a big cardboard box, like they're cleaning out their garage or something. So you can see, like, there's some miniature taps here. There's a 080 tap and probably another one. So I probably paid $1 each for each of these things and had them clipped together. I kept them have them in here in my fishing tackle box, which is dedicated to micro fasteners. So excited about that. Just a tip, you know, if you need to order a drill like this, it'd be crazy expensive. It's way easier. Always look, and if I find stuff at a sale like that, I'll just grab them up. I always bring an extra $20 or something with me just for stuff like that. There's the setup. As you can see, I've got the Shoreline vise. It's clamped in that little ledge in my soft jaws, and I first centered the slot there in the vise. So basically it's just a little over 100 thou. So I centered that with a small wiggler. Then I put the pointed wiggler in there, and I indicated an X mark on the y-axis for the top one, and then the distance for the second one. I wrote it down so I can come back tomorrow and go into mass production. I will tell you, it was a bear to pick up those little index marks. You can see I've got my little jeweler's loop. I used that at first to try to peer down in that slot. And then I also used my Optivisor, which is very handy, but I kept running into things as I'm trying to crank my head down low enough so I could pick up the little faint line in the slot. So if you're going to do this, probably finding a better way to indicate the spot would be a little bit better, but I think this is going to work. What I'm going to do to double check, right now I'm going to take the wiggler out and then put in a very fine point 60-degree drill, and I'll test that just to see if I'm getting an accurate spot. A center drill, one of those long skinny center drills. We'll double check our accuracy. Not sure how well this will show up, but I ended up putting a 1/16 inch end mill in, turning the mill on, and then coming down just to make the little flat spot for the at the 1/16 inch in. So I think that's the right spot. I'll come back. I'm going to use this very same 16th inch end mill just to give a nice flat spot for the drill to dig in, because as tiny as the number 56 drill is, it will deflect if there's not a good start for it. And you don't want it to deflect and go off around the outside of the pin and break. That would be very bad, obviously. Final shot for the evening here, kind of prove the concept. I hope that shows up. I'm going to try to zoom in a little bit. And it's just really tough because the camera doesn't really know what to focus on, I guess. But you can see there's the number 56 drill, and I used a pecking drill motion after I made the flat spot, and I made a good deep flat spot, but I just did a few thou at a time and pulled it out, just eased my way through, because you know you're dealing with really tiny, you know, wire diameter tooling here, but it's clear it made a hole. Let me see if I can. There we go. Can y'all see that? You can see the hole there anyway. So we'll come back tomorrow and do the other one, and then do all the remaining, all 18 of them, and show you what it looks like. Well, completed all the pins. It was actually more fun of an exercise than I thought when I first looked at the plans. I'm glad I came up with that idea about using the Shoreline vise to hold them. I did have to do a little bit of filing with these tiny little Riffler files, and highly recommend having a set of those if you're going to make a small locomotive or its associated parts. So I did double check the wire fits in all the holes, and the number 56 drill held up without breaking it. That's a nice thing about using brass. So mission complete. On to the next part. Alright, here we go. I'm going to zero my x-axis because that's the depth of cut. So far I've cut 52 thou according to that, but I'm not going to talk for this. I'll just make the cut because I want to fully concentrate. I do have the carriage locked down. You can't see that probably, but all the way through. Bring it back. I don't know if the camera picks it up or not, but it's starting to clean up nicely inside there. I'm going to take a couple more cuts till it's all the way cleaned up, and then I'll mic it. There's a lot of material that needs to be removed, so I'm pretty sure that I'm not anywhere as close to it yet. I'll cut the camera off and bring you back when we made a little more progress. Okay, I'm going to declare victory on this. I just used my large, well, that's large to me, but telescoping gauge to mic the inside of the opening there, and just checking it. I've got micrometers, but just did it with the digital caliper, which is perfectly accurate, and it's 1.814. We're shooting for 1.813, so a thou and a half more than I needed, but I'm perfectly happy with that. And I will take this off and get it ready to mount on the rotary table, so tomorrow hopefully we can drill the holes and cut it in pieces. Pardon? Well, here's the completed blank, and luckily, look at that, it matches up perfectly with the drawing that I made. So I need to get the rotary table set up. I've already locked it down on my mill over here and roughly centered it. Tomorrow I'll use the centering indicator and get it dialed in exactly, and I can lock everything down with the DRO. It's already zeroed for the rough centering anyway. And then I've got to figure out a way to mount and hold the jig in place, or excuse me, the brake disc in place. Well, the next thing I want to work on is the brake disc, actually making the 8 separate brake shoes. This is what the plans look like. It's a little complicated. You got to turn the outside diameter to a certain size, inside diameter, and with a 3-degree angle, which is for the taper on the wheels. And then the most complicated part, of course, is drilling these holes in this specific pattern, different angle degrees, separation apart, 22.5 and then 15. So the drilling part, I think I'm going to do that on my rotary table. That's my I think that's going to be the easiest way. I mean, I could try to program a bolt circle into the mill, but you know, if you mess that up, then you've ruined the whole part. Laying it out kind of manually on the actual cast iron piece itself, and then doing it bit by bit, or hole by hole rather, on the mill using the rotary table, I think is going to be a lot easier. Will be for me. So let me show you what I did. I spent a little time looking at the drawing, and I drew it. I used my little compass and stuff, and I drew it out, and I planned for, I'm going to do the hole pattern like this. I'll start here, will be my 0, and then I'll use the rotary table to advance 22.5 degrees to drill the first hole, then an additional 15 degrees to drill the second hole, and then lather, rinse, repeat all the way around the circle. So I've done that, like written down for each hole which you know, what degree setting it'll be on the rotary table. So that'll take a lot of mystery out of it, and if you're doing this, you could freeze the frame and copy the picture. The other thing I did was to measure the actual cast iron. The inside diameter, I need to open it up by 178 thou, so that's not that much. Outside diameter, remove 152 thou to get it to its proper dimension, and then the thickness is a total of 70 thousandths. So once I'd figured out the game plan, the next thing to do is to see the work holding and figure out how I can hold it. So as you can see here, I've got my great big 3-jaw chuck. This will be used for turning the inside diameter. I just wanted to do a little dry run and see if that works. For the outside diameter, I've got the 5C, the really small 3-jaw, set up in the lathe, and I'll show you that. I'm about ready to do that, to face it off front and back, so I'll get it to thickness on that, and I'll turn the outer diameter, and then all I'll need to do is to put the 3-jaw chuck in, and then do the inside diameter and the 3 degree angle. So let me rearrange things, and I'll show you the setup on the lathe. Well, here's my setup. I've got the little 3-jaw chuck that mounts to the 5C over here, and it works perfectly for holding from the inside by expanding the jaws to hold the cast iron disc in place. So I've got that set up. I've got a carbide. I don't use a lot of carbide, but on cast iron it's a good idea. And also I've got the bedways protected with an old t-shirt. So first step is to face off the back, and then I'll do the outside diameter to the finished diameter. Then I can flip it around, grip it from the inside again, and face off the front to the proper thickness, and then remove this and put it in the 3-jaw for the actual for the turning of the inside and putting the 3 degree angle on. And I've got my guide there to help me in case I forget anything. Well, just stopping the action real quick, I got the back side faced off nicely, and I've turned the outer diameter. See how nicely this cleaned up. You can see all the debris, the nasty debris from the cast iron, but it cleans up really nice. So now this is not the final diameter on the outside. I figured since I have a reference surface here, I'll take this out, flip it around, and then finish the final dimensions while it's around on the other side. Here's the brake ring. Got both sides faced. I got it to the proper thickness, and I've cleaned up the outer diameter. I actually made it a little bit smaller than it's supposed to be. Kind of aggravated at myself for that, but let's go ahead and put it in the 3-jaw and see if we can get the inside right. Here's the beginning, the setup for doing the inside of the brake ring. I got the 3 degree angle set, and I checked it, and as you can see with the angle there, it's going to give me the ability to cut the inside cone, so to speak, so it'll match the wheels. And I'm using a carbide cutter and like a little boring tool. Still got the directions set up. What I'm going to do in a minute, I'll set this up on the tripod so you can watch a pass or two, because it is kind of interesting. You crank, you don't feed you know, through the regular controls. You increase the cutting depth with this axis here, the x-axis, but the Z control is through the cross feed, obviously. And if you're wondering about the popsicle sticks, there I mic'd them all and I got 3 that were exactly identical, so I've got a safe space to put the cutter into, because otherwise the ring would be flush against the 3-jaw, which I did not want. Well, I found a block of wood that I've used as a previous drilling base for projects like this, so I cleaned it off and I'm going to use that. I've got my clamps very loosely in place, and I tried to use I put a longer arm on the coax indicator, tried to use that, and it was just not practical. It wasn't working. So let me show you this bizarre thing I've got hooked up here now. I've got a boring head with just a plain piece of 1/2-inch steel in it, and I've adjusted it carefully so it just made contact, and I can move it all the way around, and it seems like I've got this thing pretty close. I bet you it's within about 1/10 or so. What I'm going to do now is tighten up all my clamps, remove the boring head, and put the coax indicator in there, and we'll see how accurate I actually am. Okay, I promise I'm not making this up. All I did was tighten these things down from the last segment to now. I tightened these things down by hand. I wish I'd have made them tighter. And then I removed the boring head, and I put the coax indicator in there now with this longer stem on it. Look at that thing. Less than 1/2 thou deflection. Oh my gosh, I cannot believe how accurate that is. So now I'll tighten them down very tight, and then in fact I'm going to add an extra, because I just realized I'm going to have to remove one of these pretty soon here. I'll have to remove that one to start drilling. So that's the only frustration with rotary tables, is holding stuff down. Is like, I need to make some smaller fingers, like some Joe Pye style fingers, because these things really get in the way. I wish I could just go to town and drill all the holes. That would sure be handy. Anyway, I'm thrilled that the accuracy came in. I'll tighten things down, add the extra clamp, and then double check it again. Okay, yay, I got all 16 of the holes drilled. No problems. I did obviously have to move the clamps around a little bit, but and also, you probably already know this, but I've put a little magnet inside a trash bag here, and this way I can brush off the iron filings, and you can see them and go, the magnet holds it. So I haven't vacuumed or anything. This is just me being tidy as I go around the circle. So all the holes are drilled now. The next thing I want to do is put some markings in for my cut lines, and I think what I'm going to do is take the drill chuck out, put a collet in, and put a little tiny round end mill, and just mill a little line. I think that'd be the simplest thing for making my cuts, and just for the cutting it in the 45-degree quadrants, and then I can come back. I can draw the shapes manually, but you know, you want to have some kind of orientation so you cut them in the right place, obviously. So yay, celebration, woohoo! Here's a good view of the milling the little slot. So I got a 1/16 inch end mill in there, making a 20 thou deep slot just for orientation. I can freehand draw the the shape of the brake shoes myself, obviously, but this one, I just had to move this one clamp out of the way to make this cut. So it looks like I'm gonna have to move it again. I'll move it back, but you can see the idea. I think that's a nice, if you're going to use this setup, go to all this trouble, probably a really good idea to mill a little line there to help you with the cuts. Well, before I take everything apart, I just needed to take one short video. Really pleased with how all this came out. It certainly had a little bit of trepidation about setting all this up. So hopefully this video will be helpful to you if you have a project like this, certainly if you're building a Raritan flat car. So anyway, now that everything's done, I need to take it apart and lay out the actual cuts, draw out the little segments there, cut it all out, and then we'll be finished with this part. We can move on to something else. Maybe the wheels will be next. Well, I have to admit a mistake here. Generally, I was very pleased with how the machining went, everything on the rotary table, the whole setup, everything with this part. And I got it off and started looking at it last night before I went in, and I realized if you study the drawings, you can see the right half looks one way and the left half is like the mirror image of it, not a continuation of the same pattern. And guess what I did? I made a continuation of the same pattern. So in essence, I made 8 perfect right-hand sided brake shoes, which then my first thought after that was, okay, no problem, I'll just cut it in half, and for these, I'll just grind the 3-degree angle a different way. But I realized if I do that, that's going to set the geometry off, and all this stuff is obviously carefully thought out. So my next thought was, maybe there's a way to salvage what I've got and basically take the shape that I'm looking for with the brake shoe and lay it out opposite of how, you know, so that they're in the right dimension, but opposite of what they would be if I, you know, had continued on with this plan of making them all right-hand sides. So what I did was I've sketched out a little thing where I can cut this out and actually lay it on the part and try to lay this out. But the idea is there'd be a big gap here, and then 5, 6, and 7 could probably be normal. Number 8 might actually be a little shorter, but I'm thinking maybe it won't be that bad. Still have the correct geometry and everything, and just a smaller amount of braking surface. So I'm about to lay that out, but I did want to point this out. So don't follow me here, or you can for the first 8, but the second 8 have to be the reverse, the mirror image. So, oh well, let's see if I can fix this problem. Here we go. I think I've worked out a decent solution here. If you notice, let me hold the flashlight this way. There we go. If I'll do 1 through 4 normally here, like on the right side, like it's supposed to be, and then at about a 1/16 of an inch from the hole, I've marked off what will be the leading edge of the properly arranged brake shoe number 5. Let me put this in place so you can see I made a cardboard template and traced around it. So this will be 5. That'll work. This will be number 6 right here. 7 right there. And I have the proper orientation, proper holes and all that stuff. And then number 8 will be the one that's slightly cut off. This part right here where the little line is the part that'll be cut off. So it'll have probably about 60% of the brake shoe that it's supposed to have. You can get an idea of the wasted material up here, because this one won't start until right there. The lines, that's only a 20 thou deep score with a 1/16 inch. So that's immaterial basically. So I think that'll be the best solution in this case. If I had another disc of cast iron, I would probably try to make another, but I don't, and I think this is going to provide satisfactory braking. So that's my solution. I'm going to think about it one more night before I cut these in pieces, but I'll bring you back for when they're cut, and we'll show you what the finished product looks like. Well, just another thought about the fix, as it were. What I decided to do, I blued the whole thing with my blue Sharpie, and then I got a silver Sharpie marker here that outlines it a little bit better. As you can see, I'm using a couple 1/8 inch drill bits to line up my little pattern, and I drew around it to show where each of the brake shoes will be. I needed to do that anyway to cut them out. So here's the correct ones on the right side. 1, 2, 3, 4 would have been correct. Then 5, 6, 7, and 8 can all be full size, and just the reversed pattern, the mirror image, if you will. Then 8, the last time I looked at this, my first thought was, well, I'll just make it this, I'll just cut it off here so number 4 can be full size. More I got to thinking about it, I thought, well, I'll go ahead and sketch out the pattern size for number 4, and then see where it intersects the pattern for number 8. And that way they can each be just slightly shorter. Basically, instead of one being a 1/4 inch shorter than it ought to be, they can each be an 1/8 inch shorter. And that way they'll be balanced and uniform. I'll just put them opposite each other on one of the wheels. So that's the game plan now. I'll show you after I cut those all out and grind them to shape what they look like. Well, after marking out the disc, I've gone ahead and made the initial cuts just to cut down on the grinding. I did the little angle cuts for all 8 of the brake shoes, and here's the hybrid one. Let's just call it the hybrid one at the back. So now I'll cut them apart, cut it all clear of the ring, bring you back for that. I'm using the bandsaw. Let me show you. I wonder if the visor will show up in the reflection here. I love the OptiVisor. I've got that on for detail work, and I have this bandsaw. It's a Harbor Freight bandsaw. I've had it rigged up like this for probably 12 years. I've bolted it to a plate of aluminum and a little angle iron, and it's in my vise, and it makes a perfect little metal bandsaw. It's loud, so I've got hearing protection in if I sound funny. But other than that, this thing is wonderful, and I use the Harbor Freight blades. And I do have a woodworking bandsaw that I made for myself years ago. Made that in 1984 from a kit from the Gilliam Manufacturing Company. Did a separate video about that if anybody's interested. But that's enough about bandsaws. Let me go ahead and cut this out, and then I'll bring you back and show you the little pieces. Okay, here's all 8 of the brake shoes liberated. You can see number 4 and number 8 came out not too bad considering all the consternation. So pretty excited, and cut up pretty clean. I'll just take them over to the belt sander now and smooth off the edges and bring you back, show you what the finished product looks like. Alright, here's the finished brake shoes. Really not a bad salvage job if you ask me. Number 4 and 8 are just slightly shorter than they ought to be, and by shorter than all the others in the pair there. So pretty happy with how that came out despite my stupidity. So at least you can all learn the lesson from me about that. Now that we got the brake assemblies made, the next thing I want to do is make this little bending jig that in the plans they talk about using some 5/8 inch key stock or square stock and drilling a 1/4 inch hole down 2 pieces, then separating them and soldering them to a backing bar to make this little bending jig to use like this. Well, I happen to have a bunch of 5/8 inch steel bar that I think Russ gave me from when he was working at a machine shop, and rather than go buy something new, I decided to use the steel bar and bandsaw it out a notch 1 3/4 inches wide by 5/8 inch deep in this piece. And now the next thing I'm going to do, now that I've got that nice flat bottom, I've got a couple of 1/4 inch round end mills. So I'm going to mill, instead of drilling, I'll mill a trough 1/4 inch wide and 1/8 inch deep into the edge to make the bending jig. I'll bring you back when I've finished the milling the round slot. I've just cleaned out, after bandsawing this roughly to shape, I've just cleaned out the bottom of it. Okay, here's the finished product. Went an 1/8 inch deep, 1/4 inch wide, and you can see this is how it'll set in there. The bars that are to be bent, and they'll be put in the vise like this with a 5/16, I believe it was, rod in the place where my finger is tapping, and then the vise tightens it up and bends the bar. So that's the idea. Good use of a piece of gifted steel, so pretty excited about that. Thanks again, Russ. And I'll bring you back and show you what that looks like for the bending. Now here is the box with all the parts that we've built so far and machined. And I guess in this episode all we did was the brake shoes, the bars that we bent, all the clevises and pins. But we're at a very good stopping point right now. I guess so. I'm going to call this the last segment of this week's episode, And next week we will get on with actually machining the wheels, and that'll be exciting, and we can finish up the trucks pretty quickly after that. So long everybody. As always, thank you for being part of this journey. If you have a question, please ask. If you don't have a question but like to encourage me, please hit the thumbs up button. It does motivate me. And we'll see you soon. Thanks.